righty. Let's do this. Quick and fast. And this is like a very easy paper, don't? Look easy. Easy. It was easy, don't? Somebody online said easy, don't? Yeah, this was the last exam that CSEC said.
You should change the innovation. You know, it matters to your eye. Get it like Angry Bird.
Mute the mic, please.
Hello.
Mute the mic, please.
Because it's so normal, this.
All right. Let's work through this paper, guys. January 2024. January 2025, sorry. This is the very last exam CSEC said. So this should give you a clear idea of the structure of the paper. All right? So after this one, we would have exhausted all the papers, this class, all the way down to about 2010. Every single one of them would have exhausted in this program. So maybe next week, we'd have basically be repeating. And I don't know how I'm going to do it yet. But for next week, might have a session with us to some topic by topic. Some persons expressing interest in doing certain topics. Some person want circuit theory, some person want transformation, some person want vectors. So might have a session next week where instead of doing past papers and you're doing a mock exam, we do topic by topic. Maybe a couple hours on each topic, something like that. Or maybe what I should do, have a session next week where you bring your question that you want me to do. From all the papers, you bring the question from all the papers that you want me to explain again. And we can do topic by topic that way. But you are finding the questions that you want me to explain. And that's what it's about now, really, doing questions. All the theory and everything, the teaching of the topics, there's nothing new for me to tell you, really. It's just for you now to gain the understanding of what I'm trying to explain, and maybe to find that one or two things that you maybe just not seeing that's causing you not to get it. So it's just practice, guys, practice. As I always say, if you do a question, you didn't get it right, don't understand it fully, just keep doing it. Repeat the same question a number of times. And sometimes something just like you get a eureka moment. And say, oh, that's what I was missing all this time. Sometimes what the problem is that we do a question, and make a mistake, but the genesis of the mistake is not in the moment of making the mistake. Sometimes the genesis of the mistake is earlier on in the question. And that's why I always say redo the entire question. What happens to us sometimes, we go to the mistake at the point of the mistake and make the correction there. Sometimes it is something before that stage in the question that is triggering you to make that mistake. And that's why I always say redo the entire question. All right, so we can maybe pick up on that line at that point in doing the question that is causing the mistake. All right, so let's go. I know that everything is in the head, guys, just to put it all together. Everything is in there. Just for you to put it all together now. That's what it's about. And we're going to maximize on this last week that we have in terms of the volume of work, right? And try to close all little gaps that might exist. All right, that's what we're going to do. So start compiling the particular questions that you might want me to explain, start compiling them. I know that the thing that you're missing is in the question somewhere. I'm telling you, it's in the question somewhere. Why? Why I know that? Because all mathematical principles can only be fully understood by solving questions. By actually solving questions. That's how you fully understand anything in maths. So that's why we have to just keep solving a lot of questions now to enhance and improve the understanding. All right? That's what it's about for the next week until we do that first paper. For the record, for those online, after the paper 2 exam, we're going to have some sessions. We're going to binge on the paper once. right? Because we're not taking the paper one for granted. So people can look out for those sessions as well. We're gonna spend some lengthy days, some all dayers, let's call it that, mathematics all day, and some multiple choice. So look at, for example, all the different ways they might ask a particular question. That's what CSEC do. They will have one question and ask it 5 different ways, 6 different ways on different exam papers, but it's really the same question. And, you know, since we have access to those things, it kind of makes sense for us to maximize on the use of those things, you know? You know, in a sense, we have access to those things and we don't maximize on them. All right? So that is it. All right, let's get to the question now. Enough talking. Let's do this. Let's do this. I'm leaving the calculator on the screen because most times, first question is always a calculator question, as it is with this one as well. And so it says, use a calculator or otherwise to work this out. Now this is saying 2/3 off. This means 2/3 times. Just taking 2/3 and multiplying all of this. Hit the calculator. So the off means times. That's the only thing there. So it's 2/3. The off means times. We're gonna put a bracket. Inside the bracket, we're gonna put those fractions. First one here is 1/8. 1/8. Then this is plus. We're doing 5/12. 5/12. Make sure you enter it correctly in the calculator. What did I do? Clear it. Let's start over. Wow. My mistake. 2/3 times bracket 1/8 plus 5/12. And then that's a divide. That's a division sign. Divided by, that's 1/9. Close bracket. That looks like it. Just check that what we're typing here is the same thing that they have here. Just check, make sure. All right? Just that the off, go put in a multiply for the off right here. Put it in red. That off means multiply. All right? And so checking that everything is there. Look at it as a fraction. And it is 31/12. We want that mark. It is equal to 31/12. And they said in exact form. That is it. And we can put this one as well. 2 and 7/12. 2 and 7/12 as a mixed number. Much marks for that? 2 marks for that. We want that 2 marks. Let's continue. Then I want us to work this out. And we have to give the answer in standard form. Remember, instead of saying standard form, they can also say scientific notation. It's the same thing. Standard form, or they could say scientific notation. So if you're doing a question and instead of saying standard form, they say scientific notation, it means the same as standard form. Again, I'm going to put this in a calculator. So it's 314.2. That looks like 5 multiplied by 100. And then we are subtracting a fraction. Let's enter those digits carefully. 26082. 26082. That's on the numerator. And the denominator, that's 52164. 52164. Make sure you enter the values correctly. And that is 313.7 initially. 313.7. But I want it in standard form. It means that we need this decimal point to be here. Let's show that in red. We need that decimal point right here. To get it there, we move in 2 places to the left. So we are dividing by 10 squared to move it 2 places to the left. To cancel back that division by 10 squared, we multiply back by the 10 squared. This calculation in here will move the decimal point for us and put it where we want it. And so the final result is 3.137 times this 10 squared. See, 10 squared means that the number is in the hundreds. This number is in the hundreds. That's why it's a 10 squared in the hundreds. That is it. 2 marks for that. But I got that one. Beautiful. 4 marks so far. Nice. All right. So this question actually had an error on it. I was looking at the paper and I found that this question had an error, missing information. This part of the question could not be completed without some information up here. So I am the one who actually changed it and just put in the number 12 such that the proof will work. That to kind of work the question backward to realize that this had to be 12. But the actual paper said several cases, and CSEC make that kind of mistake sometimes. This question, you can't work it out without this piece of information. This is another question you set up. So if you're in the exam and you find a scenario like that, don't waste your time. That's why I tell you to give each question a limited amount of time. Imagine in the exam, you know you're supposed to can work out this question, but you can't work it out. Why? Because there is some missing information or not enough information. And you're there trying to work it out. You know you're supposed to be able to work out this thing. And the time going away. That is why I say to you guys, have to give each question a specific amount of time. Once that time has elapsed, you move on to the next question no matter what. Chances are, if the question is giving you problems, it is giving somebody else, giving other people problems as well. So don't worry about it. Just move on to the next question. All right? CSEC make mistakes. They put mistakes in the questions all the time. It is nothing new. All right? That's what happened with this question. So for this question to work, I had to put 12 cases here. And that's why I made that change. All right. So it said Jim packed 12 cases of juice for sale. Each case had 24 boxes of juice in the ratio, or in 3 different varieties: apples, orange, and pineapple. So 3 different varieties of juice. Remember, there were 12 cases. Each case had 24 boxes. 24 boxes is in a variety of apple, orange, and pineapple. And they said those are in the ratio 2 to 5 to 1. 2 to 5 to 1 is a total of 8 parts. All right, so let's set it up. It says here, how many boxes of pineapple is in a case? Is in a case. How many bottles of pineapple is in a case? So remember, it's 24 boxes. How many boxes? It's 24 boxes in there in the ratio that. But this part of the ratio is for the pineapple. This one on the ratio is for the pineapple. That's 1/8. But understand that? So the number of boxes of juice in a case will be 1 out of the 8. Total parts of this ratio is 8 of the 24 that was in there. That works out to 3 boxes. 3 boxes of pineapple juice in the case. But I can appreciate that. 3 boxes in 1 case. Remember, guys, we're working with 12 cases in this question. But in 1 case, you have 3 boxes. So it means that the total boxes we're looking at in this question is 36. 3 times 12. Let's get that in your mind from now. But let's continue to work for the remainder of the question. It says the profit gain from selling all the boxes of pineapple, all the boxes of pineapple. So all the boxes of pineapple is going to be 12 cases times 3 in a case. That's 36 boxes is all the boxes. But I can appreciate that. 36 boxes, 12 cases, 3 in a case. That's the total number of boxes. And they are all sold for $35.64. That's a selling price for all of them. So if you want a selling price for one of them, you have to divide this by 36 to get the selling price for one of them. But this is the profit for all of them. Oh, this is the profit. Oh, this is the profit. All right. So you want the profit then for one of them. You're going to divide this total profit gain, right, by 36. All right, that's the profit. And it says now each box is sold for this amount. Each box is sold for this amount. And it says, show that the cost for a box, 1 box, is $2.35. Show that the cost for 1 box is $2.35. So we need to bring the calculation. You can bring the calculation down to 1 box. So this is the profit on all 36. So the profit on 1 box It's this amount divided by 36. All right, so let's write it out like that. The profit per box. Profit per box is gonna be $35.64 divided by 36 boxes. What is work out to? Let's write that out. So it's 35.64 divided by 36. That's 99 cents is the profit on each box. That's 99 cents is the profit. 99 cents, 0.9. $0.99 is the profit on each box. And it says, if this is the amount for one, this is the selling price, and this is the profit, then you're gonna subtract these to get the cost price. Let's set it up. See here, the profit, remember, is equal to the selling price. Let's write SP for selling price. Selling price minus the cost price. This question, you're trying to prove the cost price. To prove the cost price, you calculate it. So you want to make the cost price a subject. So we can take the negative cost price, bring it over here, and take the profit and bring it over here to get the cost price. So the cost price is going to be the selling price minus the profit on one box. So that is going to be the selling price is this. That's what they sold it for. $3.34 is subtracting the profit of 99 cents. And that gives us this proof of $2.35. So the cost is $2.35. And that is shown. All right, but understand that work? 3 marks for it, I want it. Anybody got it?
Yes, sir.
Nobody got it. Or some person got it. Yes. All right, good. So if you didn't get it, why we work it again? It's not complicated. All right? Not complicated. You see the read information. All right. All right. This question says now, calculate the percentage profit made on the sale of the boxes of pineapple juice. So the profit percent is the profit over the cost multiplied by 100. So the profit percent is the profit divided by the cost price multiplied by 100. That's how you get the profit percentage. It's always a profit percentage on the cost price. All right. When you do accounting, we talk about margin. Margin is how much you gain relative to the selling price. But forget about that. Forget about that. So the profit is 99 cents. So that's 0.99. Over the cost that we just worked out was 235. Multiply that by 100 to get it expressed as a percentage. So that's what we're working on. So it's 0.99 over 2.35. Multiply that by 100. 42.1%. 42.1%. Given our answer to 3 significant figures. Very good. All right, let's continue. Question done. Hope you all got 9 marks on that. So like somebody got 6. Or maybe less. Anyway, let's go. Any question you get wrong, go and do it. This one now, don't need a calculator now. So the copy of this document not so clear, but this is actually x squared minus 49. This is actually x squared minus 49. I'm factorizing the difference of 2 squared because this now is the same as x squared minus 7 squared, because the 49 is the same as 7 squared. That factorizes it into the difference of the numbers x minus 7 times the sum of the numbers x plus 7. Want to go to that? Nice and easy. Yes. I don't want to factorize that as I try to know me quadratic. All right, this one is the factorizing. But the only factors of this x squared is x and x. Then you need factors of the 35, where the difference is 2 in the bracket. So this one, you don't really need a process to do this one enough. You don't need a process to do this one. Let's look at it now. The only factors of the x squared is x and x. And they want factors of the 35, where the difference is 2. Oh, I know the difference I want. Because it is a negative 35. So it means that to get the middle term, my far product and my near product will have to have a difference of positive 2x. What two factors of 35 have a difference of 2? 7 and 5. Those are the two factors you want. 7 and 5. 7 and 5 are the two factors. This tells me that the two signs in the bracket are different, because if the last value is negative, two signs in the bracket must be different. This tells me that you get the larger product, the positive sign. Because remember, the middle term is obtained by multiplying the far product and the near product and add them together. The near product is the larger one, 7x. So you make that positive by putting the plus here and putting the minus on that one. That is it. Those are the two factors. If you like, you can check it. This x times this x is the x squared. The last term is negative 35, which is this 7 times this negative 5. And then the middle term 2x is the near product of 7x and the far product of minus 5x. They add to the middle term of this 2x. All right, but if you want to do it the length way and get it, fine. But we need to practice doing these things quick and fast. Much marks for that? 2 marks for that. All right. Then this one now says hence. The hence here means that we are using the results that we have up top. All right. That's what hence means. Use what we have just done before. So I want to basically simplify this expression. Recognize that the numerator is what we factorize up the top. And the denominator is what we just factorize here. So this basically becomes the factors on the numerator was x minus 7 times x minus 7 plus x plus 7. There's something wrong. Oh no. Over. The factors on the denominator is x plus 7 times x minus 5. So what happens is that this x plus 7 cancels with this x plus 7. All right, and leaves us with x minus 7 over x plus 5. It's final result. Let me reduce the size of this a bit. You understand that, guys? All right. So this reduces to the x plus 7, no, x minus 7 over x minus 5. That is the answer in simplified form. All right, that is it. Next question. Next question says you have to rearrange and make M the subject. This M right here, I want to make it the subject. Easy. Right now, it is negative M on this side. I'm going to take it over this side and make it positive. I'm going to take this S and bring it over that side and make it negative. So I'm going to end up getting M squared equals K minus S. Everybody understand that? Then to get rid of the square, we're going to square root both sides. Square root the left side and square root the right side. This square root will cancel away this square and leave us with an M. So the M alone is going to be the square root of K minus S. But I always want to remind you that really and truly, this could have been a plus or minus. Could have been a plus or minus. I just don't think CSEC will penalize you for not being a plus or minus. Because when you calculate square root, you have to remember that it can be plus or minus. But remember, for example, square root of 4. Let me set it up this way. If x squared is equal to 4, then the x can be plus or minus. The x can be plus or minus the square root of 4. The x can be plus or minus 2. Why is that? Because positive 2 squared is 4, and negative 2 squared is also 4. See that? So it's the same thing that's happening here, even though we don't have numerals there. That's why when you calculate square root as you did here, you should be considering plus or minus. I think if you put it there, CSEC won't penalize you if you put it, but I don't think they'll penalize you if you leave it off either. But a good practice is to put it there because they did not tell us anything about the M to say M is positive or negative. You don't know what M is. So really and truly, it can be plus or minus. All right? So let's appreciate that. This is a square on it. All right, let's continue though. This part down here says, Lisa has $56 to buy no more than 70 red balloons and green balloons. So no more than 70 here really means less than or equal to 70. All right? And that's a total of the red and the green balloons will have to be less than or equal to 70. That's what that means. It says she buys more green balloons than red balloons. So that means the number of green balloons is greater than the number of red balloons. Just using these letters for the time being. That's what this statement means. She buys more green than red. But must buy at least 15 red balloons. At least 15 means 15 or more. Don't let the word least cause you to write the less than sign. Look at the meaning of the term at least. If you must have at least $10 to buy something, means that you need $10 or more to buy it. So this really means that the number of red balloons must be greater than or equal to 15, right? Greater than or equal to 15, at least 15. The red balloons must be greater than or equal to 15, the number of red balloons. All right, it says now, that X and Y represent the number of red and green balloons. Okay, so the red balloons is X, and the green balloons is Y. That's the number of them. The number of red balloons is X, the number of green balloons is Y. It says, write two inequalities. I can't pick up more than two inequalities from this now, but I just only want two. Write two inequalities in X and Y other than these two, which is basically saying that the number of red balloons must be greater than or equal to 0, the number of green balloons must be greater than or equal to 0. Represent information above. I think I can get more than two inequalities, but they're only asking for two. Let's look at it. The first one is that she's buying no more than 70. In that the total number of red balloons plus green balloons must be less than or equal to 70. I'm getting one inequality here. X plus Y, that's the total number of balloons, must be less than or equal to 70. No more than that total. That's one inequality. All right. Another inequality is that she buys more green than red. That's a second one. Remember, the green is Y now. So it means that Y is greater than X. The second inequality from this statement. She buys more green than red. So the number of green, which is Y, must be greater than the number of red, which is X. Then here she says she must buy at least 15 red. Means that the number of red, which is X, has to be greater than or equal to 15. So I'm giving them more than 2 enough. That's another inequality. All right, and there's another one that we can get from the money. Each red balloon costs 75 cents, and each green balloon costs 50 cents, and this is the total money that she has. It means that the total money that she's spending has to be less than or equal to that amount that she has. Let's set it up. So the money that she's spending on the red balloon is this amount, 75 cents times X. She's spending on the red balloon. So that's 0.75 times X. That's the money she's spending on the red balloon. Plus, money she's spending on the green balloon. She's spending 50 cents on each green balloon, and she's buying Y of them. So the money she's spending on the green balloons would be 0.50 times Y. That total amount of money that she's spending has to be less than or equal to the 56 that she has. So they asked her for 2, I gave them 4. So any 2 of those I gave them, I think they have to give you a marks. I think CSEC make a mistake. I think they really wanted to put the word 4 right here. I think it's a mistake they made. But there are 4 inequalities in this statement. I really think they need it. They wanted to put 4. But I think if you give them any 2 of these, you'll be telling the truth. But that's on all of them. And normally speaking, we will simplify this one if they want to do more with it. We're just writing them and leaving it right there. But good and understand all of them, right? Which two you gave? Everybody give this one. Which other one you gave? This one. Anybody gave this one? Anybody gave this last one down here? What? On the bright man. Lovely. Because they could have asked for all four, right? They could have asked for all four. Beautiful. Let's continue. I love it. I love it. I love it. Next one says, given that y varies inversely proportional. Remember, when it's inverse, it's k over. So the first thing y, let's write it out. The first thing, which is y, is equal to k over the second thing, which is x minus 2. That's the relationship between them. K is the constant. Now, this question can be done without finding the constant, because they tell us that x equals 11 and y equals 9. We can use these values to find a constant, but we don't need to find a constant. And they want us to find the value of y when x equals 29. Oh, what you want me to do? You want to find a constant? Want to find a constant? All right, let's find a constant. So to find a constant, what we can do, we can take this x minus 2 and multiply it over here by the y to get k as a constant. So we can get x minus 2 times y will always be equal to that constant. And then to find the constant, we're going to take these known pair of values and plug it in there. So we're going to plug the x equals 11, y equals 9 in this equation. We're going to get 11 minus 2 times 9. That's what the constant is equal to. Now 11 minus 2 is how much? 9 times 9 is 81, right? So the k equals 81. So now that we know that the k is 81, we can now write the equation. Let's change the color for the last part. We can now write the equation. The equation becomes, we can write this one, or we can write this one with the k. The k is now 81. Put the 81 up there, because that constant will not change. So the equation becomes y equals 81 over x minus 2. That becomes the equation with a constant now in it. And they're asking us for the y value when x equals 29. So we're going to take the 29 and substitute for the x in there to find the y. So when the x equals 29, the y is equal to 81 over 29 minus 2. This becomes 27. 81 divided by 27 is what? 3? So this equals 3. So the answer is 3. That is the answer. All right. Sound like you all got that one as well. All right. Could have done it without the key, but all right. Leave it like that for now. All right. Very good. 9 marks for that question. Next question. Next question gives us this hexagon, and it is regular. Remember, any polygon that is regular means that all sides equal and all angles equal. All sides equal, all angles equal. And they're telling us that all sides is 8. So each of these sides is 8 centimeters. Question says, show that the value of angle PQL is 120 degrees. Now PQL will be the angle right in here. P to Q to L. That's this angle. But all angles are going to be the same because it is regular. Multiple ways to do this one. Let me show you 2 nice ways to do it. All right. It has 6 sides, right? Right? And this angle that they want is one of the internal angles, right? And all internal angles are the same. Because it is regular, all external angles also will be the same. I'm going to use the external angle approach. Watch this now. So the external angle, for example, here, if we extend this side, would be this. Let's call this theta for now. All right? Remember, all the external angles will be the same, and there are 6 of them. But the total external angle of a polygon is always.
So this is 1.
Total external angle is always 360 degrees. And there are 6 of them. So therefore, 6 times theta is 360 degrees. So theta, when you divide by the 6, the theta is 60 degrees. 360 divided by 6 is 60 degrees. So therefore, the angle inside here is 180 minus 60 degrees. Because total angle on a straight line is 180. Put another way, so the sum of an exterior and an exterior angle is always 180 degrees. So the angle that you want in there, the angle PQL becomes 180 degrees minus that 60 degree exterior angle, which is 120 degrees. That's one way to do it. Nice, easy, quick way to do it. Remember, total exterior angle is always 360. That's a key. And it has 6 sides, so it's gonna have 6 exterior angles. And they are all the same. I just put one on the diagram here. But 6 of them it has. And the total exterior angle is always 360. So the 6 of them equal, so 6 times theta is 360, means that one exterior angle is 60 degrees. And so the interior angle right here becomes 180 minus 60 degrees. Other way to do it. Another way to do it is find an expression for the total interior angle and divide it by 6.
Oh, yes, sir.
All right, so let's do it another way. So let's do it another way in purpose. So, or total interior angle is, what is it again? N minus 2 triangles, right? N minus 2 triangles, and each triangle has 180 degrees in it. That's all. The n is equal to 6, right? The n is equal to 6, so this becomes 4 times 180 degrees. That's a total interior angle, 4 times 180. And there are 6 of them. Therefore, angle PQL is going to be 4 times 180 degrees divided by 6. And that's going to work out to the same 120 degrees.
20 degrees.
They could do it that way as well. If you want to work out put the value right here, which is 720, that's fine. 720, if you want to put the 720 there, and then put the 720 up here, we'll do it that way as well. All right, so that's, I think most persons would do it that way. For the exterior angle method, I need to learn and get comfortable with that way as well. Remember, the total exterior angle of any polygon, regardless of the number of sides, is 360 degrees. Even a triangle, total exterior angle of even a triangle is still 360 degrees. All right, let's continue. This question says, it says the vertices of a rectangle, X, Y, Z, touch the sides P, Q, QL, MN, and NO at hexagon in part A. X, Y, and X are parallel. So these two lines parallel. This and this parallel. So remember, once you have parallel lines now, you can go for your Z angles, your co-interior angles, and so on, right? The question says, calculate angle LWX. That's right here. LWX is right here. Watch this now. Those two red lines parallel, right? Let me zoom it up. Now, this is also an interior angle, you know. This angle is 122, you know, right here. You know that, right? Because all interior angles are the same. Remember, this one was 120 we just found. This one is 122. Why is this one 120 as well? Because it is regular. All interior angles are the same. And they're asking us now for this angle right here. This one kind of easy because we're gonna form the U. So the parallel line and the parallel line joined by this one. These two angles are therefore co-interior angles. So this angle that they want, let's work out in purple. This angle that they want right here becomes 180 degrees minus this 120 degrees. And that is 60 degrees. I guess there are other ways to do it, but that's the way I see right now.
Like angle is in a quadrilateral equal to 360. Like the angle is in a quadrilateral equal to 360. The angle L and angle M would equal 120 and W.
Yeah, man. There are multiple ways to do it. Multiple ways to do it. So if you do it another way and get the answer, same answer, fine. That's okay. All right? There are multiple ways to do it. Multiple ways. I'm not showing this one now. All right, so if you do it another way, I get the same 60 degrees, that's good. All right, but I got 60 degrees for it inside here. Beautiful. All right, 60 degrees. So we can put the calculation down here. The angle that I want is 180 degrees minus 120 degrees, which is 60 degrees. And I'm leaving these marks on my diagram for them to see how I got it. All right, I use the co-inferior angles between those two parallel lines. All right, let's continue. This question says, following, we are to show construction lines for this question. So it's a construction question. It says the field of a sport club is in the shape of a quadrilateral. This quadrilateral right here. It says a scale drawing of the field is drawn below. This is it. What I want us to do. It says a lamppost is to be erected on the field at a point marked L, and it is so that a floodlight can be installed, right? It said the point L should be located such that, in such a way that L lies on the perpendicular bisector of the line UR. So this is UR. You want L to be on the perpendicular bisector of it, down there, right down the middle and perpendicular to it. And also the angle LST must be 30 degrees. LST must be 30 degrees. So L is somewhere in here. LST must be 30 degrees. So you need 30 degrees right here to find it. All right, and this is where L is going to be. But I understand that. So to find L, we need to construct a perpendicular bisector of this line. We need to construct this line. And we also need to construct a 30-degree angle inside here. But I understand that. All right, let's do it on the let's do it with the device over here. Let's do it and see how you would proceed to do it. So I have to bisect one side and then construct a 30 degree. Remember, to construct a 30, we bisect a 60-degree angle, right? Let's construct it. Come on, come on, come on, come on. Come on. What's up, swing up the device? All right. Come on, come on, come on. All right, ready. All right, so I'm just going to draw something similar to this, guys, so I can construct on this, right? Just going to draw something similar to this diagram that they gave us here. So I'm going to put a line up here. Then put a line down like that. I think that first one could be longer. Let me go again. All right, let's go again. A longer one up here. Then a line down like this, which is almost vertical. I'm going to put a line down like this. And then I'm going to join them. Not exactly like that, but close enough, right? I'm going to work with this diagram. So, just to show the process. So you have to do this on the actual paper. These are the points. I will sketch it before we construct it as I did on the screen there. So I sketch what we have to do. I sketch what I have to do, what we are doing, and then we're going to construct it. So we need a perpendicular bisector of this line. To get the perpendicular bisector, we're going to use the compass. And the process is to open the compass more than half the length of the line. More than half the length of the line. All right, lock it. You're going to rotate, and you're going to make an arc above the line. And you also need an arc below the line. Somewhere under here. Now, without changing the angle of the compass, you move to the other end of the line. Don't change the angle of the compass. I'm going to come and cross this arc down here. And then we're going to go and cross this one up here as well. All right, I won't be able to I won't be able to do it because it's coming off the screen. I can't get it. Let me make it from down here then. All right. I'll come back over this end so I can see that intersection clearly. That is it. All right. So the straight line through that intersection is my first line. Let's draw it in green. Let's draw it in green. So I'm coming through these 2 points to bisect the line. It's on the wrong thing. Through these 2 points. All right. So L is somewhere on that line. That line is bisecting that UR, sorry. Then I need to construct a 30 degrees down at this point. Man. The construct at 30 degrees, so the thing gone. All right, good. See, we can undo those points. All right, I need to construct at 30 degrees down here now, at this point. So again, we're going to rotate the compass over. Let's adjust the length of it. To construct at 30 degrees, we need to construct a 60-degree arc and then bisect the 60-degree arc. So a 60-degree arc is about there. Move the compass to this point. Rotate and cross that first arc. Like that. That's a 60-degree arc. I make this one a little bit longer. Over here. But I'm not going to draw a 60-degree. I'm just going to bisect that arc now. The arc between these 2 points. I'm going to bisect the arc between these 2 points. That's a 60-degree arc. I need to bisect it. I'm going to keep the blue so we can see the difference. So I'm going to bisect it, make an arc out. Oh, wrong place, Mr. Shaw. Put it in the intersection here. And then we're going to make an arc up here. That's the blue arc to bisect the angle. Move it to the other end of the 60-degree arc. Rotate and cross that one. I'm going to draw another green line now for the 60 degrees. For the 30 degrees, sorry. I'm going to draw another green line. So the green line now is going to the blue intersection from blue to blue. That's the other blue line, the other green line. That line now is at 30 degrees. This green line. Where those two green lines meet, that is where the L is going to be, right here. And such that this angle down here is now 30 degrees. And I have bisected this side over there. So that point in the middle is where the L is, right here. That's where L is. But go to that. So you bisect this one side and then construct the third on the other end, right in there. That is it. Anybody got it? All right, good. All right, so if you didn't get it, you need to go and do it from a place. You don't know what's coming on the exam paper. You need to go and do it. If you didn't get it, go and do it. You have to watch over the video. You watch over the video and you do it. All right, follow instructions. All right, so it says, we'll locate the point L, right? And that is it. That question done. Next question, number 4. Number 4 is a coordinate geometry. Again, it's a line joining these 2 points. And I want us to find the midpoint. So remember, the midpoint is like an average point. So the midpoint, let's call it M, is the average of the X values and the average of the Y values. So you're averaging these 2 X values and you're averaging these 2 Y values to get it. Simple as that. So it's this X value plus this X value over 2 minus 5 plus 7 over 2. And you're averaging these 2 Y values. 6 plus 2 over 2. 6 plus 2 over 2, yeah. A midpoint is like an average point. So it just average the values. So this and this becomes 2 over 2, which is 1. It becomes 8 over 2, which is 4. So midpoint is at the point 1, 4. Better go to that. 1, 4. Then it says Find the equation of a line segment CD. So CD says CD also find the equation of that line. So we're going to be used, we need a gradient of CD. So we're going to do difference in whatever difference in X between these 2 points, right? Gradient of 1, not the equation, gradient. So the gradient common M of CD, it is equal to rise over run. Rise is the difference in the Y values, run is the difference in the X values. And you have to decide which direction you're subtracting the value. So let's say I'm using the D point minus the C point. Then it is this Y value minus this Y value. So I'm doing 2 minus 6. Then I have to point minus this point again for the X value. So it's this X value minus this negative 5X value. That's 7 minus this X value is a negative 5. So this minus actually becomes a plus. So this reduces to what? This reduces to negative 4 over 12. That's negative 4, that's 12, which then becomes negative 1/3. Gotta go to that. All right. You guys are very brilliant around here. Very bright students you are. All right, beautiful. Next part says determine the equation of the perpendicular bisector. The perpendicular bisector is the line that passes through the midpoint and is perpendicular to CD. So let's sketch it out like this. That's what a schematic of it. Not a sketch an actual thing. Just like a schematic. Minus 5, 6, 7, 2. Minus 5, 6, 7, 2. All right. So I'm going to put it like this. So it's like you have C up here and D down here, right? And you want this line. This is the line that you want. Perpendicular bisector. That's the line that you want. Passing through the midpoint that we calculated up top, which was what? 1, 4, right? You want the line that passes through 1, 4. And it is perpendicular to CD. We're trying to find the equation of this red line, the perpendicular bisector. Let's call it line 2, so we can reference it. So to find the equation of that line 2, that red line, we need to know 2 things about it. We need the gradient of it, and we need a point. We have a point already, it passes through that point. What we need is a gradient. But because we know the gradient of this one, we can find the gradient of that one using the perpendicular relationship. The perpendicular of line 2 that we want is minus 1 over the gradient of line 2 is minus 1 over the gradient of CD. Negative reciprocal when they are perpendicular. This calculation is done. What's the gradient of CD again? It's minus 1/3, right? This calculation is done by flipping this and changing the sign. That's all we need to do. If you want to put the minus 1/3 on the here and work it out, good. But a quick way to do this calculation is to flip and change the sign. So you flip this, it becomes 3/1 first with the negative. And you change the negative to a positive. So it becomes positive 3/1, which is 3. So that negative gradient, that perpendicular gradient is 3. So using this perpendicular gradient of the red line with this point. So the equation of the red line becomes y minus the y value at M equals the gradient of line 2, the perpendicular line, into x minus the x value at M. That's how we're going to get the equation. Let me shift it down. All right? That's how we get the equation of that line using the gradient point form. We want to use y equals mx plus c and use this point to find the c. That's fine as well. So it's y minus the y value at the point is 4. So it's y minus 4 equals the gradient is 3. Gradient of the perpendicular line is 3. Into x minus x value at this point is 1. 1. And then we're just simplifying this down. Let me make this a little bit smaller. Let's make it a little smaller. So we can write the answer on it. So we're gonna take this one carrot over here, so right? So we're gonna have y equals 3 times x is 3x So the 3 times minus 1 is minus 3. And then this 4 comes over to become a positive 4. And then the 4 minus 3 is 1. So we're going to get a plus 1 in the end. So this is plus 1. But understand that? That is the answer. But get that? 3x plus 1. Y'all got it? Beautiful. 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 Next one. Another line AB is parallel to CD. Parallel lines have the same gradient. So right away, you know the gradient of AB equals the gradient of CD, which is minus a third. You know that already. And that line passes through 0, 1. 0, 1 is actually a C value of 1. You see that? Because 0, 1 is on the y-axis. So if the point is 0, 1, it's a point on the y-axis. So this point is actually your y-axis intercept. So this is C equals 1. So you have your gradient and you have your C. You can find the equation. Write down the equation. It becomes y equals the gradient of AB times x plus the C that we have here. So no calculation needed. It's y equals minus a third x plus 1. You have to recognize that this 0, 1 is on the y-axis. So it's a y-axis intercept. So the C is 1. But good? All right. 2 marks for that. We want every mark. 2 marks for that. Next question done. Let's continue. Next one, please. Number 5. It said the table below shows the marks out of 10 that 40 students in a class gain in an essay writing test. So these are the marks. Those are your scores. That's your frequency. They say that this is 40 students. So this must add up to 40. Let's make a note down here so don't forget. That add up to 40. It says, calculate the student's mean score on the test. So to get the mean score, what we can do, we can put in a sum column. We can put in a sum column in the table, add a sum column to it. And the sum column is f times x. And you multiply these values. So basically what we're saying is 3 persons score 4 marks each. So the total marks for those 3 persons is 12. So that's a quick way of calculating the total marks by all 40 students. So this is 12. Next one is what? 6 times 9 is how much? 54. Then 8 times 7 is how much? 56. Then 7 times 8 is how much?
56.
56 again. Then 8 times 9 is how much?
72.
72. Then 5 times 10 is how much?
50.
50. So the sum of your effects, sum of all the marks is the sum of these values now. Add up all of them. How much again? 300. Everybody got 300?
Yes.
So the mean is the sum of the sum of all the marks divided by the number of marks. The number of students. So it's 300 divided by 40. What is work out to? 7.5 marks. Put the word marks on it for me, please. Put the word marks on it. All right? Your statistical measures must carry the same unit of the data. The unit of this data is marks. They're going to say 7.5 marks. It's the average mark, the mean mark that the student got, that the students got. I know that you are tired. Some of them are fitting up. You're all dying here. 2 marks. Let's continue. You're all dying here. You're all dying. You have it easy. Next one says we must get the modal mark. So the modal mark is one that had the highest frequency. So the mark that corresponds to the highest frequency. Remember, it is not the frequency. It's a mark corresponding to the highest frequency. All right. So the highest frequency is 9. So the modal mark is 6 marks. Everybody see that? 6 marks. Okay, beautiful. Don't put 9 enough. So the modal mark is 6 marks. Is the answer. Next one, I want the median mark. The median mark is the one that is in the middle of the distribution. How many values are there?
40.
40. So if it's 40 values are there, it's going to be the average of the 20th and the 21st in the middle. So let's look at it. We're gonna have to count up the marks. So remember the n equals 40, right? So the position of the median is half of the n plus 1 term, don't it? The n is 40. Half of 41 is how much? 20.5. So the 20.5 mark one, the 20.5 term. That is the average of the 20th and the 21st term. The average of the 20th and the 21st term. We average them to get it. That's what we're gonna have to do. Find the 20th term, find the 21st term, and average them. So to find these terms, we're gonna have to count up the frequency. Count up the frequency. So we're gonna count up the frequency. Basically, you'll put in a cumulative frequency column, because a cumulative frequency column is a counting column. All right? So we can start count. Let's put it over here. Let's put a counting column over here. Counting column, which is a cumulative frequency column. A counting, which is your cumulative frequency. I want to add up and see when we reach 20. So adding up these frequencies. So first we have is 3. They will add this 9, how much we reach? 12. They will add this 8, how much we reach? 20, reach 20 already. So the 20th score is a 7, don't it? So the 21st score is a 8, don't it? Because it comes right after this. Good. So we know that for sure. So then we can put it here. We reach 20, we don't have to go any further. This is the 20th score. And the 21st score, the first 8 in this group, in this set. 21st. So we're averaging the 7 and the 8, don't it? Averaging the 7 and the 8. The 20th score is a 7, the 21st score is a 8. So the median is also 7.5. So it means that the Q2, it becomes 7, that's the 20th mark, plus 8 at the 21st mark, divided by 2. That is 7.5. Anybody got the 7.5? What? It's on the right. 7.5 marks. Youngster, I can't see one place. Huh? You can't see one place, man? Don't want to do that. All right, I want to change the color of this thing. Change it. Last saw it. Change it to red. All right. All right, that is it. So 7.5 marks is here. So much work you have to do to get it. All right. But I go to that. But I understand that, right? But I understand. All right, good. Next one. It says using information in the table. Using information in the table below, a pie chart is to be constructed to represent the marks obtained by the student. The marks the students gain, right? And they put them in group now. They group them now. And this must still out of the 40. That out of the 40 still. That out of the 40 still. Check it for me quick. Yeah, man, out of the 40 still. Yes. This is 15, 25. Yeah, out of the 40 still, right? All right. All right. So it says calculate the angle for the sector representing the interval 5 to 6, which is here. So to be this 9 out of the 40 of 360 degrees, don't it? So that pi angle is going to be 9 out of the 40 times the total in the pie chart is 360 degrees. That's going to be the sector for this group. What that work out to?
81.
81 flat?
Yes, sir.
1 degrees flat. Wow. You guys shutting up this test, man. Nice. 1 mark for that. All right. Probability now. This question says, the diagram below shows 2 fair 6-sided dice, P and Q, but this is not a normal dice, 1, 2, 3, 4, 5, 6, right? They cannot change it up. The first dice, which is this one, the numbers on it are 0, 0, 1, 1, 2, 3. All right? That's the numbers on this one. And then on the second one, this one is not 1, 2, 3, 4, 5, 6. It's 3 1s, 2 2s, and a 3. So I cannot change it up, right? Don't matter. Principle is the same. It says when a die is rolled, the score is a number on the top face. That is irrelevant right now. It says die P is rolled. That is this one with these possibilities. Die P is rolled once. What's the probability that the score is not a 2? So if it is not a 2, it means that you want to get these values. You want to get these values, don't it? Okay, you don't want a 2. So you want to get 5 out of the 6. That's all? So the probability of getting not a 2 is 5 over 6. Good? So it's 5. You want one of the other numbers. So that's 5 out of 6 is the answer. But understand that? Very
Yes.
good? Or you could do the probability of getting a 2 and then the 1 minus that. The total probability is 1. So you could do the probability of getting a 2, which is 1 over 6. But you don't want the 2, so you do 1 minus 1 over 6. It's going to give you the 5 over 6 same way. And the total probability is 1. All right, anyway, that's the answer. I don't want a 2. So there are 5 numbers there that are not 2. Next question. Die Q is rolled twice. So this second die is rolled twice. What is the probability that the score is a 1 both times? So remember, if it's 2 times rolling it, then it's a combined probability. So you want to get a 1 on the first roll, and you want to get a 1 on the second roll. So you're going to multiply those 2 probabilities. So you want the first one and the second one. So probability of getting a 1 on the first roll is 3 out of 6, don't it? That's 3 out of 6 on the first roll. Multiply on the second roll, you can get 3 out of 6 again. But all the numbers are still there when you roll it again. Another 3 out of 6. That's really half times half, don't it? Which works out to be 1 out of 4. 1 out of 4. Very good? That's probability of getting a 1 2 times. Next question says, the IQ is rolled 72 times. Calculate an estimate of the number of times a score 3 is obtained. So what this is, you have to find out what's the chance of getting a 3 on one roll, and then you multiply that by 72 to see how many times, to see how many times you can get a 3 in 72 tries. What's the chance of getting a 3? Is 1 out of 6, right?
6, yeah.
The chance of getting a 3 on one roll is 1 out of 6. But you want to get it on 72 rolls, so you multiply this by 72 and work that out. What that work out to? 12. So you can get 12 times, possibly. And that's just an estimate. All right? Very good? All right. Beautiful. Next one, sample space. So sample space really it shows all the possible values that you can get. That's what the sample space shows you. It shows your possible outcomes for a set of data. All right. This says each die is rolled once. So they're rolling the 2 of them now. It says the product of the score is recorded. So this is the product of the score. So you see that's where they put information for one die down here. That's the P. That's the Q, sorry. And then they put the values on the P1 down here. So this one is the Q. This one is the P. And they're multiplying the values. So 0 times 1 is 0. Then 0 times this one is 0. So all of these is going to be 0. Because 0 times any one of these values up here is 0. All right? You're multiplying them. Then it's 0 again times all of these is 0. Then the other values are 1. 1 times all of these is going to be bring by the same values over there. But I understand how this is populated. You're multiplying the values to get the values inside here. So multiplying the values on die Q with the values on die P. So these represent the product of all the possible combinations. So there are 36 possible combinations of the product that you can get. And they're all inside here. 6 by 6 is 36. 36 possible values you can get as the product from the two die. 2 dice. 2 die. What the plural? Dice or die? Die. All right. It says find the probability that the product is a 2 or a 3. So it means that you want 2s or 3s. So you want all of the 2s and all of the 3s. So you want all of these. Let me mark them. All of the 2s and all of the 3s. Let me mark them. See them here? That's what you're counting up. How many is that? 12. So it's 12 out of 36. So you want a 2 or a 3, so you have to add them up, right? You will accept a 2 and you will accept a 3, so you add them up out of the 36. So that's 12 out of 36. That equal how much? 1/3. But good at that? All right, good. 1 mark for that. Next question. Circular measures. Once you see the pie, you know circular measures. It says a piece of wire is 61 centimeters long and it is bent to form the sector. So it means that the perimeter of this sector now is 61. That's what it means, you know. The perimeter of this sector is 61. So the 2 radii here plus the arc add up to 61. That's what it means. That's what they're going to have to do. All right. All right. It says the sector of a circle OPQ, center O, and the radius is 18. So if this is 18, then over here is also 18. This is the radius. And we don't know what this is yet. We can get it in terms of x. It says show that the value of x is approximately 80 degrees. So what would be this side over here? This side over here, this length over here would be x over 360, sorry. X over 360 times 2 pi r, don't it? This would be an arc length. This is an arc. That arc length would be theta over 360. In this time, the theta is x. X over 360 times 2 pi r. The r is 18. 2 pi times 80. But understand that. Using length of arc. Length of arc, remember, is theta over 360 times 2 pi r. Let me write it out. Arc length is theta over 360 times 2 pi r. So this is the expression for the arc length. What it means is that this plus this equals 61. Nobody can appreciate that. Let's simplify this one. This time this is 36, don't it? And 36 divided by 360 give me 110, don't it? Let's simplify this one. This simplifies into 36 over 10, give me 1 over 10. So it becomes 1 over 10 times this. The pi is 22 over 7 times this x, which becomes 22 over 70, but we can reduce it even further. Because we can go 2 into this goes 5 times, and 2 into this goes 11. So 11 over 35, right? So reduces to 11 over 35 times x. That's the length of this piece up here, the arc. So the arc plus the 18 and the 18 must equal 61. That's how we're going to get the angle. But understand that working out? Good. Let's do it now. The length is 31. So see here now, the 18 plus the 18 plus this, which is the arc, which is 11 over 35 times x must equal 61. I'm solving that for the x. So this is 36, we're going to subtract over here. So the x is going to be 61 minus 36. The 18 plus 18 is 36. I'm subtracting it there. I get one expression. Then I have to multiply by this 35, multiply by 35, and divide by this 11. Divide by the 11. If you want to go step by step, this is supposed to give you 80. Somebody work it out for me. And them say approximately. See? That's why them say approximately. So basically that is it. But I understand that working out. I don't have a lot of space. I can't do no work for steps. That's why I do it. It's kind of quick and short like that. I don't have a lot of space. So basically that is the equation. I simplify it down. And you're gonna get, how much you get? All right, so this thing to get 9.5, I'm going to put approximately 80 degrees. And therefore shown. I wonder if everybody understand the calculation that just went down. But I understand it? Good. You know that the perimeter of the sector is 61. What we did not know was the arc length. We don't know the angle, so we had to get the arc length in terms of the angle, which is x. So another way you could do it, as what you say, you could say 61 minus these two first and get that remaining piece. Then the arc length will be equal to the 61 minus those two. That would work as well. All right, good. No problem. That's a nice way to do it as well. All right. But that is it, 80. All right. It says calculate the area of the enclosed wire, which is now the area of the sector, right? So that area is the area of the sector, theta over 360, which theta is really x. There's x over 360 times the area of the circle would have been pi r squared. That's what we're working on, right? So this becomes 80 over 360 times pi, which is 22 over 7 times 18 squared, the radius squared. What does it work out to with the calculator? Anybody? So nobody got this one right then. I don't want nobody saying that. 226, 226, and it is centimeters, right? Centimeters squared. Right, centimeters squared. That is it. But good. That was just the area of a sector, which is theta over 360 times pi r squared, a fraction of the area of the circle. All right, let's continue. This question says, a cylindrical block of cheese has a radius of 12 centimeters and a height of 8 centimeters. It says the cheese is divided into equal slices. The uniform cross-section of a slice. Okay, so this is just one slice of the whole cheese. So the cheese is cylindrical like that. That's not what they're saying. And what they do, they cut one slice out of it. But I understand that. Because a cylindrical block of cheese. All right, and I cut one slice out of it. All right. So the uniform cross-section of a slice of the cheese is a sector whose angle is now 18 degrees. So remember, the total on the cheese would have been 360 degrees, don't it? Around the center, right? And they cut it up in equal slices, right? Equal slices, and one of the slices come out to be 18 degrees. So if you want to know how many slices I have, you just need to divide 360 by 18. But I understand that. Let's do that first. So the number of slices, let's put it here, slices, it's going to be 360 for the total in the whole thing divided by 18. What I work out to? That's 20. So that 20 slices, 20 of these they get, right? From the whole cheese. All right, so everything that they set up here is on the diagram right now. We'll just work out that is 20 slices they got. It says calculate the length of the arc AB, that is arc length. That's a fraction of the circumference. So it becomes 18 over 360 times 2 pi r, and the r is 12, right? 2 pi times 12. Let me write out, let me put the values and then put the formula above it. So it's 2 times 22 over 7 times 12. The formula is theta over 360 times 2 pi r. That's the formula we're using here. Fraction of a circumference. What this work out to? 3.77. All right, so it's 3.77 centimeter. I'm shift this over a bit. 3.7.
Sir, if you run it to 3.8, that's fine.
Yes, that's all right. But it's good practice to work with 3 significant figures when the answer is not exact and they don't tell you what to do. It's good practice to use 3 significant figures. But if you put the 3.8, they give it a mark still. It's only 1 mark. They cannot not give it a 1 mark for that. We're going to work with the 3.77, 3 significant figures. Next part says, determine the area of the curved face, ABCD, that's this face I want. So basically, it's going to be this length times this length. Everybody can see that? So if you flatten it out, it becomes a rectangle, right? So it's the arc length plus the 8. Easy. So it becomes the arc length plus the 8 times the 8. So it becomes the 3.77 times the 8. That becomes the area of this space right here. So what I work out to? 30.
30.16.
30.16. You know, I could put 30.2. 3 significant figures. All right? But 30.16, that's fine. Centimeters squared. Yes?
How come on the side of which like CSEC will be 20 to like 40 to like a certain number?
They're not going to tell you that all the time. That's why I just work with a standard rule that says when they don't tell you, just work with 3 significant figures. Let's work with a standard rule. So not every question they're going to tell you what you must do. Standard rule is if they don't tell you and the answer is not exact, put it to 3 significant figures. Let's work with that. All right. Next question says, given that the area of OABC is 22.6. Oh, so OABC is on the top. That's the cross-sectional area they're giving us right there now. So this is the cross-sectional area right now. Remember, this becomes a solid, you know, this becomes like solid geometry now, you know. So this is one end of the uniform cross-section. This is the other end. So 8 becomes the distance between them, between the two ends. So this is like the L. Remember, objective uniform cross-section, the volume is cross-sectional area times the L. L is the distance between the two cross-sectional ends. And the cross-sectional end in this shape is the one at the top and the sector at the bottom. And this is the distance between them. So the 8 becomes your L. All right. Now this question just gave us the area at the top. So what does it say? It says, given that the area at the top, this is the end area, A. I would know that the L is equal to 8. It says, calculate the volume of the entire block of cheese. The entire block of cheese is 20 of these, don't it? So it's 20 times the volume of each slice. So, but understand that. So the answer for this, the volume of the block becomes 20 times the volume of a slice. And the volume of a slice is the end area times the length. So it becomes 20 times the end area, which is 22.6, times the length, which is the distance between the two ends, which is 8. But understand that. This volume, remember, volume of an object with cross-sectional area is end area times the length. So we're applying this for the volume of the slice. That's going to give you the answer. What does this work out to?
2,616.
3,600.
And 16.
Oh, 3,616. And that is centimeters cube as its volume. That is it.
Where do you think it comes from?
People getting it right. Lovely. Aha. Like when students get question right. It's very good. Love it. Love it. All right. Number 7, pattern question. It says a sequence of pattern is made of dots and lines of unit length. Some of these lines form squares. The first 3 diagrams in sequence is shown. All right, let's look what is that in now. So they started out with this. I can see it in this one still, right? So what they're adding is this little thing right here. So they're adding these and they're adding these dots. And these in the middle. So they're adding 3 dots. And how many lines? 1, 2, 3, 4, 5, 6, 7 lines. So they're adding 7 lines and 3 dots. In essence, they're adding this thing that I've shaded out in red. So to get the next shape on this, we just need to add this onto this shape right here. So they're putting a box here. They're putting a line over here. Putting a line up the top here. Putting a line down here. And then they're putting in the dots. A dot here. a dot here, and a dot in the middle of the square. That's what they keep adding. But I go to that. So that's what I've drawn in red will form my next shape. But good? All right. Make sure you get these things right, you know. Too easy. Come on. Make sure you get these things right. Look at the pattern and just continue the pattern. Question says, the number of dots D and the number of unit lines that form each diagram L form a pattern. So number of dots and the number of lines, they form a pattern, the number. The value of D and L for the first three diagrams are written in the table below. Study the pattern of numbers in each row, and we have to complete the rows 1, 2, and 3. The question is always the same. So we're completing this row, this row, this row. As usual, we like to do the formula row first because it helps us with some of these sometimes. Let's see if this is an easy formula. So the number of dots increasing by 3. We saw that in the pattern, don't it? So 3n, since it increased by 3, 3n is a part of the formula. But the first figure has 5 dots. 3 times 1 is 3, so we have to add 2 to complete the formula. That is it. The number of lines increasing by what? 7, don't it? Plus 7, plus 7. So since we're increasing by 7, 7n starts the formula. But the first shape has 8. 7 times 1 is 7. We have to add 1 to the formula to make it match that first shape. So that's the formula. All right. Then for this row, this is the next figure. Figure 4 is the next figure. So we can add the 3 to this to come continue. So this is 14. And we can add the 7 to this, don't it? So this is 29. So that one easy. Very good. Then for this now, we need to equate this to this formula to find out what the number there. That's the easy way to do it. All right. So to find the n for here, we're going to put the formula equals 59. So we're going to put the 3n plus 2 equals 59. That's how we like to calculate the formula first, because it helps us here. Subtract that 2, we're going to get 3n equals 57. 57 divided by 3 is how much?
19.
So n equals 19. So right here is 19. I know that we know that this is 19. We can take the 19 and drop it on the end formula there to get the figure for this one. Let's show the work over here now. So this one is calculated by putting the 19 on the 7 there, on the end there. 7 times 19. 7 times 19 plus 1. What does it work out to?
134.
34. Beautiful. So that is 1 mark for each of these numbers. 1 mark for this, 1 mark for this, 1 for this, 1 for this, 1 for this formula, 1 for that formula. 6 marks for this question. 6 marks. Next part now says, one of the diagrams in the sequence has 148 lines. So these are the lines. So we're going to equate this to this now, right? Calculate the number of dots. So we're going to find the n and then calculate the number of dots from it. See that? That's what we're going to do. We're going to use this formula to get the n, and then we'll find the n. We're going to use this to calculate the number of dots. But let's agree with that. Good. Let's do it that way. All right. So we're going to use that to find the n. So we're going to write 7n plus 1 equals 148. So 7n equals 147 when you subtract. So n equals 147 divided by 7 is how much? 21, don't it?
21.
And then now that we know that that is 21, then the number of dots is going to be this formula. 3n plus 2, which becomes 3 times 21 plus 2. 3 times 21 is how much? 63 plus 2 makes 65, don't it?
Yes, sir.
Yes,
65 dots. 2 marks for that. Beautiful. 10 marks for this question. All right. 3 more to go. Then we can go home. What time is it now? We're going to pass 9 o'clock a little bit, but that's all right. Nobody will die. Let's go. Let's run them fast. Functions. This question gives us these 2 functions. That's a rational function. So you see they tell you x can equal 1. Because see, the denominator can be 0. They could have asked that question enough. What value of x cannot work on this function? 1. What value of x is this function undefined? It's when the denominator equals 0, meaning when x equals 1. But I put it in there this time. X cannot be 1 on this function. It makes the function undefined. But anyway, the g is equal to this. So let's write them out this way. So f of x is 1 plus 3x over x minus 1. And the g of x is 5 minus x. Same thing. And I want f of -2. So I'm going to put the -2 inside the f function up here. Let's work it out in purple. So this one is going to become equal to purple, I said. This one is going to become equal to 1 plus 3 times -2 over -2 minus 1. But understand that? What is work out to? This is 1 and minus 6 at -5 up there. Let's make this smaller. Hold on. Let's make this a little smaller right here. Let's lasso it. Let's make this a little bit smaller. All right. Right. So this up here works out to be -5. Agreed? -5 on this and here become -3. Agreed? The negatives cancel, so we get 5 over 3. Very good? Next part wants us to do f of g. So like the same question on all the papers. Don't get them question wrong enough. Don't make no sense to set them about the same thing all the time, get them wrong. Putting g into the f. So it means that we're going to take this and put it into the f right there where the x is and put it here as well. But understand that. That's how we put g into f. Simple as that. And set up that construct. It means that the f of g of x becomes this construct that we just draw there. We put in the g into the f. So it's going to be 1 plus 3, where the x is, we put in the 5 minus x, divided by, where this x is, we're going to put the 5 minus x there. And then we have this minus 1. But I go to that. We're going to simplify it now. Let's simplify it. So this up here becomes 15, right? 15 and that one makes 16. So the number becomes 16. Then this is 3 times minus x, that's minus 3x. Then on the minus 3x, Mr. Shaw, we make this a little smaller. Why 6, you really don't give a lot of space to write, you know. You write large, dog, and you suffer. And then now, working this out now. So this actually becomes minus x by itself. And it is 5 and minus 1 is 4. So we get 4 minus x. But I go to that. 16 minus 3x over 4 minus x. Then I want us to do f to the minus 1 of this rational function. You see, comes from time to time. This is one that requires a little bit more steps. But the process is the same all the time. So this is to practice it. It's 3 marks for that, you know. 3 marks for that, you know. You don't want to give away that 3 marks because you don't practice rational function. Let's set it up. Come on, man. It's too easy. Let's set it up. And they don't give a lot of space to do it either. So it's f equals, we're going to call it f. Leave off the up x for the time being. 1 plus 3x over x minus 1. 1 plus 3x over x minus 1. They don't give a lot of space, guys. Let me just make it small and zoom up. They don't give a lot of space for it. I'm going to make it small and zoom up, right? They don't give a lot of space. All right, we're going to form the inverse function now. So this x, this f becomes x. And this x and x becomes f to the minus 1. Some teachers use x and y. Same process, still have to transpose. I'm using 1 plus 3 times f to the minus 1 over f to the minus 1 minus 1. So this is my inverse function. That's the range of my inverse function. I need to make that the subject. So the process now is to make this thing your subject. Simple. Expand it out into separate terms first. So take this denominator and multiply it across here by the x first. So remember now, it's x times this and x times the minus 1 as well. So you get x, f to the minus 1 minus x. equals, this numerator stays the same. 1 plus 3 times f to the minus 1. You need to get the terms in f to the minus 1 on the same side. So I'm going to take this and bring it over here and subtract it. Take this minus x, bring it over here and add it. So I'm going to get x f to the minus 1. This comes over here and become a negative 3f to the minus 1 equals. This one is on the right side, it stays there. This minus x comes over and becomes a positive x. But good so far? Then what we do here next to leave one f alone in the expression is that we'll factorize it. Factorize the f to the minus 1 out of this. F to the minus 1 out of this gives us x. Out of this gives us negative 3 equals 1 plus x. Then to finalize it now, let me write this part up here. Let me write this part up here. Let's move this part up here. They don't give a lot of space to work, guys. Right? So we're going from this step to this step up here. So you see how I got it, right? Then now that we have this, we can take this expression right here and just divide it. The same as saying you're dividing both sides by x minus 3. But the shortcut method is to say we take it, so as it is multiplying over here, bring it under here and divide it. Cross multiply, cross divide. So we're going to get f to the minus 1 equals 1 plus x over the x minus 3. That is f to the minus 1 of x. I'm going to put it back off x now. This is f to the minus 1 of x. And this is the answer right here. Guys, it don't make sense to lose 3 marks for that. I don't practice transposing those rational functions. Practice it. The same steps all the time for all of them, almost. Same steps. Don't make no sense we're doing this from last year. And people still have a problem with this. But it's the same steps all the time for almost all of them. Don't make no sense to know that something can come on the exam and you don't practice and get it right. These are supposed to be sure marks questions. Sure marks questions. Questions that are set repeatedly over time. You have to get these questions right and get the full marks for it. Come on, man. Come on. This can't be no problem for you. We're doing this from last year. Let's continue. Don't put in the work, you won't get the result. This question says, the velocity time graph below describes the journey of a car over a period of 70 seconds. Now remember, for a velocity time graph, 2 things to remember. 1, gradient is acceleration. 2, area under the graph is distance traveled. Those are the 2 main things they get from a velocity time graph. All right? Question says, complete the following statement. During stage 4, where's stage 4? Stage 4 is this flat line up here. The speed is constant up here, so there's no acceleration up there. Because the speed is constant, and the speed is this value right here, right between the 40 and the 50. That is 45. They like to ask about up here a lot when they give velocity time graph. That flat section. This section flat as well. Right here, the speed is constant as well, and the acceleration is 0. When speed is constant, your acceleration is 0. Acceleration is 0 when you're not changing your speed. It don't mean that you're not moving. A lot of persons believe that when acceleration is 0, you're not moving. No. It means that you're moving at a constant speed. Uniform speed. Your speed is not changing, but you're still moving. Like you're cruising in a car at one constant speed. You are not accelerating. You're not speeding up, you're not slowing down. You're going at a constant speed, so the acceleration is 0. CSEC like to ask questions about these flat sections where the speed is constant. It is traveling at the 45 up here. See there, 45 meters per second. Put 45 right here, so that is the speed, 45 meters per second with an acceleration of 0 meters per second. 1 mark for this, 1 mark for that. When the speed is constant, the acceleration is 0. Come on, I can get these things right. Next part says, determine the maximum acceleration of the car during the 70 seconds. Where was the acceleration maximum? Meaning you're looking for with a gradient, which part of the graph are the highest gradient. And because I say acceleration, I'm only interested in the parts where the speed was increasing. Speed was increasing on this part and on this part. So those are the 2 parts I'm going to analyze. Over here, that's negative acceleration, which is retardation, deceleration. So I'm not going to analyze this part. So to find the acceleration, we just need to calculate the gradient of each part and see which one of them is larger. So they can look at it and note, but let's calculate them. Gradient is rise over run, just the same. So the gradient on this part, let's work it out. The acceleration on this part is rise by 20, run by 15. Note it. So you rise 20 meters per second and you run for 15. What I say that? So it's 20 over 50. What I work out to? Huh?
1.3 current.
Meters per second squared. That's acceleration on that part. Up at this part, we're gonna do the same thing and see what the acceleration is up here. That one look like it might be more. So the acceleration on this part is what? Rise by how much? How much you rise by here, so? That is 10, 20, 25. That rising by 25, and you're running by how much is that? You're running by 10. That's 25 over 10, which is now 2.5. So therefore, that is the maximum, don't it? 2.5 meters per second squared. I'm leaving these calculations on my diagram. Make CSEC so I get it. I'm not going to calculate it again. On the bottom there. So I'm just going to write it down here now. It is 2.5 meters per second squared. I'm going to say C diagram for my calculations. That's how I'm get me 2.5. If I guess it. So my diagram, I got it. What I got? It's a maximum acceleration. Anything else? It says, calculate the distance traveled by the car during the first 25 seconds. That's the area under the graph between in the first 25 seconds. That's what you want. Let's look at it. So the first 25 seconds is actually here. So I'm going to move this out of the way. That's why I encourage you to write with pencil in the examiner guide. So something you have to move things. I encourage writing with pencil in exam, believe it or not. All right. So the area that we want, first 25 seconds here, right? So we want the area inside here. So that is the area that we want. Area under the graph up to 25 seconds. That gives you the distance traveled. Area of jack shaded area is the distance traveled in the first 25 seconds. That's a trapezium. Because these are the 2 parallel sides. This side and this side parallel in that trapezium. And then this is the distance between them. What can I say that? What are the parallel sides? This side is 10. Let's write them out. This side, let me use a different color, purple. So up here, so it's 10. This side is 10. This side is 25. And the distance between them is 20. 20. 20 is the distance between them. So it's 10, 25, and 20 in the trapezium. You have a trapezium. If you want to break it up into a rectangle and a triangle and add them, fine. But you must can find the upper trapezium, guys. Come on. Half the sum of the parallel sides multiplied by the perpendicular distance between them. 10, 25, and 20. Come on. So this area, this distance equals area shaded. I'm going to tell him it's my area shaded on my diagram. Area shaded on my diagram. Which is half the sum of the parallel sides, the 10 and the 25. Multiplied by the distance between them, which is 20. But understand that. Even though the area calculate, the answer is in meters because the distance. Even though the area calculated. Don't put a m, don't put a meter square. The units work out themselves. Because the speed is in meters per second and the time is in seconds. So the seconds cancel. That's why you left with meters as the answer. But I understand that. Good. So the answer is in meters. What is work out to? 350 meters is the distance. If you don't put meters, you might lose a mark, you know. Put the unit, because the question asks for a distance. You can't just write 350. 350 meters is the distance traveled. All right, that question done. You look like you're gonna die, all of you. You're lazy like what? Next question. The diagram below shows a circle with center O and the points P, Q, L, and M line on the circumference, circular measures. It says Ln equals NQ. So this is an isosceles triangle. These two sides equal. So this is a nice big isosceles triangle right there. So these two angles equal. See that? All right. Note that, note that, note that. It says Rn is a tangent. Rm, sorry, is a tangent. That's a tangent at L, and the angle is 63 right here. That's between the tangent and the chord is 63. So if this angle between this tangent and this chord is 63, stop talking. Then the chord, this chord is gonna itself subtend the same 63 degrees at the circumference up here. 63 up here. Remember the triangle is isosceles, so down here is 63 too. But I can see that. So figuring out some stuff already before we even start. So figuring out some stuff. Let's calculate. That's what I want us to do. It says explain why angle X, that's this angle up here, and angle NQL, that's this angle up here, are equal. It's the same segment again. You know, so almost like the same question asked on the people that we did earlier today. Both of them are subtended by this chord. See it? That angle is subtended by that chord. And this angle is subtended by the same chord. And both of them are in the same segment. Both of them in the same segment across that chord. So the same segment rule. Same segment rule. That's because angles in the same segment are equal. I think the main thing I want to say is this. I want to say the term same segment. Angles in the same segment are equal. Let's finish it. When subtended by the same chord. They are both subtended by this chord. And they're also subtended by that arc. We can leave it like that. But I think if you just stop right here, angles in the same segment are equal, I think they give it a mark. If you just stop right here. All right. Next question says, determine the value of each of the following angles. Show detail, give a reason for your answer. Angle X. Angle X we just find a while ago. Angle X up here. All right. Angle X. Angle X equals 63, you know. Don't it? Because angle X is subtended by this chord. And the chord is making an angle of 63 with the tangent. That's the alternate segment rule. I will call it the tangent and chord rule. So it means that the chord subtend the same 63. So angle X is 63 degrees, right? So notice I don't put any degree on X this time. So we can put the degree on the answer. So angle X equals 63 degrees. You have to write the reason. The reason is the rule. Angle between tangent and chord equals angle subtended by the chord. That is it. You have to learn to write the rules. They're forcing you to write the rules now. All right. Next one. Angle Y. Let's look at the diagram for angle Y. Let's look at it. Angle Y. All right. So angle Y is this angle right here. Now remember, we just set up here that this angle, these two angles are the same, right? So we can put them on the diagram now, you know. So we just worked out that this angle is 63. And this angle is also 63. We said that they were equal earlier. Explain why they were equal earlier. And then now, because this triangle is isosceles, it means that this angle down here also is 63, don't it? 63. And then total angle in this triangle is 180. So therefore, this angle Y is 180 minus the sum of those two. No, sir? So that angle Y is 180 degrees minus 2 times 63 degrees. What I work out to?
54 degrees.
54 degrees. The angle is 54 degrees. I'm going to tell him that, see my diagram. This angle is 54 degrees. I'm just going to give a reason. Total angle in the triangle, right? So I'm going to say, see diagram for the calculations. I got an isosceles triangle, right? So total angle in the isosceles triangle is 180 degrees. So that's why we had a 2 times 63, right? Because the triangle is isosceles. Mr. Mills, little boy, hey, you know something about talk to your mother about you. Next question. It says 2 ports, E and G, are on level ground, 245 kilometers apart. That's this one. That's a bearings question. It says the bearing of E from G is 302 degrees, but I don't show it. I'm going to put on the diagram. So it's E from G. Remember, when you're doing bearing, you must always note the from position. It's very important, guys. So it's from G to E. I'll put in the bearing at the from position G. This is G, and it's G to E. The bearing is 302 degrees. Let's show the 302 on the diagram. So at the from position, it is clockwise angle from the north line all the way around to the line, taking us out to G. The bearing of this direction is 302. So this is the 302 degrees right here. 302 degrees. Put it on the diagram. It's going to help you when you see it on the diagram. Don't just leave it in the words there. When I'm reading up here now, I'm looking if there's anything that they are saying that is not on the diagram. Anything they say that is not on the diagram, put it on the diagram. When it is on the diagram, you will see how to use it. All right? That's why you read and put what they don't show on the diagram. It says, a ship is anchored at F down here. And some distance away from G, that distance away from G, we don't know what it is. On a bearing of 222 degrees, 228 degrees. So they're giving the bearing now from here to here is 228. Let's put that on as well. 228. Let's put on a different color. So again, it's from here down to here. We want the bearing now. This is the same north line. So the clockwise angle around to here. That angle that's taking us down to F, that direction, is 228 degrees. That blue angle, 228. Let's write it here, so. So it's 228 degrees. That blue angle is 228. But I go to that. So the red one is 302. The blue one is 228. I go next time I use colors too, when they would have 5 different color pens: green, red, blue, black. Yeah, you can't penalize you for doing that. Help yourself. All right. It says angle EFG is 52. So this one is shown on the diagram, so we're good. It says this information is shown in the diagram. See, they tell you this one is shown in the diagram, but they didn't show the other two. All right. It says on the diagram above, insert the 228 degrees. See there, we have done it already. So we have done what they said. The bearing of F from G. So we do this part already. 1 mark for putting on that angle in blue. It says determine the value of angle FEG. So FEG is the angle up here they want. FEG. FEG. That's the angle that they want. All right. So we're gonna get that angle.
228 for the changing.
Huh?
The 228 for the changing and 2 and then add the values together and then take away from 180.
All right. I'm not hearing what to say. Let's work it out. You're not hearing you here? Not hearing you. All right. So I want to find this angle, but because we have this and we have this up to here, we can actually find the angle in between here. The difference of these two, right? 302 minus 228 is the angle inside here. What I work out to? This angle inside here is
74 degrees.
4 degrees, sir.
74 degrees. And then total angle in the triangle is 180. And that's how we're going to find this one up here now, right? So this one is going to be 180 degrees minus the sum of these two. Minus the 74 and the 52. What I work out to?
54.
54 degrees. All right, beautiful. So down here, we're going to say 54 degrees. I want to say C diagram again, because we have a calculation on the diagram. All right, we're going to 1 mark for it. All right, that is it. Anything else? It says, calculate GF, the distance, calculate GF, the distance 2 ships from P. I don't know what I said properly. Distance ship is from Port Q. All right, GF, that's one GF. GF is this distance here. So to do that one, we can use sine rule, don't it? Why we can use sine rule? Because we have this pair. We have this pair of angle and side that are opposite each other. So once you have that pair of angle and side opposite each other, we can use sine rule in the triangle. So when you use that pair, these two, along with this, these two, you use sine rule, okay? Let's set it up. Sine rule. Angle and side opposite each other. So we're trying to find this side FG. So sine rule, let's do it on the screen and then copy it down. So sine rule for FG, sine rule for the FG. Start with what you want. So it's FG over sine of the angle opposite, which is 54. So it's FG over the sine of 54 degrees equal the side that you know, which is this side, 245 over sine of the angle opposite the 245, which is this 52 down here. Then to make this a subject, you take this sine of 54 and multiply it up here. Remember, always put it behind the multiplying constant. Put it behind the number, don't put it in front. So we're gonna get that the FG is equal to 245 times the sine of 54 degrees all over the sine of 52 degrees. But I understand that. All right, let's copy this down now and then work it out. Let's copy it down. Put down, paste it down here. Let's put it here. So do it in front of the diagram so we can see what we're using. And then now all we're doing now is just finishing this calculation. And that is the answer. All right. What is the work out to? 251.5.
Yes, sir.
Yes, sir.
251.5 and is a distance, it's kilometers, right? It's kilometers we're working in. Distance is kilometers. Yes, the distances are in kilometers. That is it. Next part says, indicate the point H on the line EF such that GH is the shortest distance from G to EF. And then determine the distance GH. All right, so I want to put H on EF. And it must be the shortest distance from G to EF. All right, so it's basically a perpendicular distance I want. So putting a point on this line H, right? Let's put it on in green. And it has to be the perpendicular distance from here. That is the shortest distance. So this is where the H is gonna go. And this has to be a perpendicular distance for it to be the shortest distance. But understand that? So this is the distance I want now, GH. Good? Now remember, we just worked out this angle, this side, you know. So we can work in that triangle now as a right angle triangle, don't it? We find this distance GH using this 52 degrees. Very good? That's a right angle triangle. What was this distance we got a while ago? We just got it a while ago. What was it? 251. 251.5 kilometers. So when you use what now? Sine. This becomes the hypotenuse. It is opposite the 90. So it's the hypotenuse. And this green side that we want is the opposite, right? So when you use sine of 52 degrees, let's work it out and then copy it down. Sine of the 52 degrees equals the opposite side GH that we want over the hypotenuse, which is 251.5. So to find the GH, we're going to take this 251 and multiply it up here. So the GH is going to be equal to 251.5 and the sine of 52 degrees. That's what we're going to get. So let's copy this working down here and then work it out. All right, so copy this, cut it, and put it down here. So that's the working out we want down here. All right. Therefore, GH equals what? This calculation is here. What you get?
198.18.
198.1. Huh?
198.2.
And that's kilometers. That question done. Now, one more to go. One to go. It's only 9:14. No good, man. I'm working on that. You're all good. Come on. One question. Vectors. Let's go. Hey, the first time CSEC give a vectors question with 3 different components, you know, X, Y, and Z. They always only just give two components. So, but it don't matter. The concept and the principles and the approach is the same. Vectors at this level is basically how you go from point to point. It's simple. Keep it simple. All right. This question says, the diagram below shows a quadrilateral in which O is the origin. It says OL is 4Y. That is it right here. It's on the diagram. Good. And OM is 6C. That's right here. That's on the diagram. Good. And ON is 2X over here. Good. So everything that I've said so far is on the diagram. So the point A lies on LM such that LA to AM is 1 to 2. Let's put in that information. So the point A is on this line and it breaks the line in the ratio of 1 to 2. So it means that, let's put on in red. This is 1 part, this is 2 parts. So the total parts on the line is 3. So this represents 1/3 of the whole line, don't it? And this represents 2/3 of the whole line. Everybody say that? We can leave the 1 and the 2 on it. And they say B is on MN. This MN. And same thing happening. 2 to 1. So the BM or the MB part up here is 2. This is 1. So again, we're going to put the 2 and the 1 on it. So the 2 parts and the 1 part. Total part on the line is 3. So this here represents 2/3 of the whole line. And this represents 1/3 of the whole line. So we're keeping those numbers on there. So that reminds us That is 3 parts, 2/3 and 1/3. All right, that information is important. It says express in the simplest form the vector mn. And I want it in terms of the x and the z. So this is kind of easy because we have the portion vector of the m, which is this, and we have the portion vector of the n, which is this, right? So it's O times the last minus O times the first. So mn is on minus om. O times the last minus O times the first. That's the easy way to get displacement vector when you know the position vectors. So the on is this one, 2x, minus the om is this one, 6z. That is it. X and z in the answer. That's it. Very good. Nice and easy. Next part says, find in terms of x and y now, the simplest form ln. Let's look at the diagram. ln. So on ln. Again, we're good. We have two position vectors, right? We have position vector of the L and we have position vector of the N. Let's work out on the screen and we'll copy it down. So on ln. Again, it is on minus ol. O times the last minus O times the first. The on is this one again, 2x. And the ol is 4y minus 4y. That is it. Simple as that. Let's copy this down. I'll cut and paste it down where we want it. Let's do it on the screen so everybody can see what we're doing. Put it right here. Paste. That is it. Then this one now says we have to find the vector AB and show that it is that. Now, look here, simply enough. To show that this equals this, you just go about calculating what this is the normal way. And then when you get it, you express it in this form. That's all you have to do. We'll look at the diagram and see how we can go from A to B on the diagram. All right? From A to B. Let's look at it. A to B. All right, let's look at it. We're going from A to B. All right. So to go from A to B, what we can do, remember now, we can come up here first. And then we can come down here, so don't it? But I say that. So basically then, we can go, let's write it out up here. We go from A to B. We're gonna go A to M first. And then we're gonna go M to B. All right. Now remember we have the MN already, don't it? We calculate MN already. Calculate MN already, don't it? And the M to B is 2/3 of MN, don't it? This part of it is 2/3. But did we calculate LM? No, I don't think we calculated LM, right? No, we didn't calculate LM. So we need LM to get the AM, because the AM is 2/3 of LM. So let's work out LM over here. So LM right now is OM minus OL. And the OM is 6Z, don't it? 6Z minus the OL is 4Y. 4Y. That is the LM. Now, this AM is just 2/3 of that, don't it? And so we can write this, don't have a lot of space. It's 2/3 of LM. So it's 2/3 of that. So it's 2/3 of 6C minus 4Y plus MB. Now MB is 2/3 of the MN, don't it? So I'm gonna add this 2/3 of the MN. And the MN, remember, is this one, right? 2/3 of that. So it becomes 2/3 of 2x minus 6z. That's what we're working out. So you can see that the 2/3 6z here cancel the 2/3 of this 60. But cancel that? The 60 gone, don't it? The z gone, you know. This is going to give you a 2/3 6z. And going to be minus in a 2/3 6z. So the 6z gone, the z gone out of the expression. So we're left with 2/3 of 4y, of negative 4y. Let's write it out. 2/3 of this minus 4y and 2/3 of this 2x plus 2x. That is it enough. That's what it is. That's what they told us to prove. Let me see what they told us to prove. See there, same thing. See there? 2x minus 4y. That is it. Done. That is it right there. Just turn these around. Turn those around. So I'm going to copy this down. It's not complicated, guys. Not complicated. Just look how you go from point to point. But the paste down it. Make this small. Right? And we also need this information as well. But we needed the LM. So cut and paste down here. We needed the LM. Right? So this now can be shown, because this is the same as this and this is the same thing. Just turn around these values in here. So it becomes 2/3 of 2x minus 4y, which is shown. But go to that. But all right, the vector work out itself. Just look where you go from point to point, it work out itself. All right, work out itself beautifully. All right, next part. It says, based on your result in part 2, state 2 geometric relationships between LN and AB. All right. So we're looking for, once the question asks a relationship between lines, usually about them being parallel and stuff like that. All right. So LN and AB. So this was AB, right? So AB, let's work it out. So the AB was this one. Let's work it out. Remember the AB is 2/3 of 2x minus 4y. What was the ln again? What was the ln again? Here's the ln. Oh, it's the same thing, 2x minus 4y. And the ln is 2x minus 4y. So basically then, it's like we can take the ln and substitute in here, so don't it? Because the same thing, right? So the relationship is that AB is equal to 2/3 of ln. But I can say that because this is ln. This is really ln. See, there is ln. So the AB is 2/3. And I want two relationships. Now this, because one is a multiple of the next, it means that they are parallel, right? And the next thing is that the length of AB is 2/3 of the length of ln. I could also express as a ratio for one. The length of AB is 2/3 the length of ln. That's what it also means. So two things happening here. One, they want two things. One, they are parallel. AB is parallel to ln. That's the first thing. Because one is a multiple of the next. That's why they are parallel. And now the relationship of the length is also built in this multiple. So AB, the second thing is that the length of AB. Because if you take the modulus of both sides, you're gonna get the length of the vectors. Right? So AB is 2/3. The length of AB is 2/3 of the length of ln. So let's try that. Length of AB is 2/3 the length of ln. All right. Could have also gone and given a ratio. Let me show you. Could have given a ratio as well. From this, you could have given a ratio. If we take the modulus of both sides, what we would end up getting, we drop out the arrows, we could get AB equals 2/3 ln in terms of length. You have to get the vector if we're going to show a ratio, but you cannot divide directions. And we can divide the ln, and this becomes AB over ln equals 2/3. So the ratio then means that AB to ln is 2 to 3. So we could have given this as another relationship, the ratio of the length of the lines. All right, but I think these two that we gave is good enough. All right, last part now. Last part down here. Matrices. This question says, determine the value of the unknowns in each of the following, in each of the matrices equation below. Matrix equation below. So these are the unknowns. And this is just addition, right? So looking at it, this 4 plus this x equals this -3, don't it? So we can write that. 4 plus x is -3. Take this one, carry it over and subtract it, we get -7. X equals -7. But good. The y now. This -2 plus this 8 equals this y, don't it? All right, so right here, -2 plus 8 is equal to the y. -2 plus 8 is 6, so y equals 6. Easy marks for that, easy marks. Good. Then we're coming down to here now. What the value of the a and the c? This is a multiplier now, right? So let's set it up. We have to use this column. So this 10 is this row times this column. But I can say that. But I can say that, right? So we can set up like this. Let's set up like this. It means that 5 -3 row times the column AC is equal to that -10. First element times first element. Second element times second element. So this is 5 times A, that's 5A. Let's put it over here. 5A, and then -3 times C is -3C is equal to this -10. I'm doing it that way because we're going to get two equations. Two unknowns, we're going to get two equations, right? And then now, the other value that the AC affects is this one, because it's in the first column. So this row times this column is giving us that 17. All right? So let's set it up again. So the row 2, 3 times the column AC is equal to 17. So let's do it again. So this 2 times this A and this 3 times this C gives us the 17. So that means that 2A, that's 2 times A, plus 3 times C, 3 times C, that is giving us 17. Wow, so we get two simultaneous equations. That is easy to eliminate the C by adding them, don't it? So we have a minus C, minus 3C and a plus 3C. We're going to add these two equations. Just add them, and these will be eliminated. So simply, the 5A and the 2A is 7A. These are eliminated. 17 and minus 10 give me 7. So the A equals 1. Don't it? And divide by the 7. Then if the A is equal to 1, we can take the 1, for example, and substitute it back in this to work out what the C is. So we can say, and taking the 1 and putting it here, we will get 2 times 1 plus 3C equals 17, don't it? Now this 2 times 1 is 2. 2 goes over there and subtract from the 17, give me 15. So 3C equals 15. And so the C equals 5. We divide by the 3, I get 5. So the A is 1 and the C is 5. So these are my two answers right here. That's an answer. And that's another answer. End of this test. And that is that. When I'm going, I want to hear some score when I'm going. I want, hey, don't tell me the score, don't come back to my class, you know. I want to hear some scores. That is it, guys. That is it. Let's get on the first one. Yeah, the work to do. You got some work to do. All right. Let me hear what you ask that before you leave. Huh? Where you get that? I'm not see. I don't know. Feel here on that play. Where you get? Let me see. I want to see. All right. What you get, mom? I get everything. Keep on your own. Ready again. Next one. Once again. Come here. Come tell mom to get. Try around this. Try around this. Come and tell mom to get. Come. All right, good. Come here, the three of you around here. Hey, Miss Jackson, don't leave now. Miss Jackson, Dejanay, come here. Come here, man. Come here. You never tell me to get on the first paper. Come on, tell me to get on this one. Come. You didn't tell me to get on the first paper. Oh, you don't need it. No, work every day. Eh? We're gonna do it, man. We might be down week after next.
I did all the people once 2014 to 2024. So you can send me
One answer. Just send me a WhatsApp and answer. Send me a WhatsApp. I think I look here. I put a lot of them in the group, you know. Check the group. People want solution. They are in the group. So let's check the group. Let me see your work. Huh? Let me see your mark. We have to miss. Let's see. Where the mark?
the one mark.
Where the marks? Where the marks? Come and tell me score. I'm not seeing the mark on the sheet. A joke, kind of. Start just and them start play game. One thing on them. Listen, I pinch you. Eat too much food, that's the problem. Come here. I'm not going. I know you want to get. All right. Which one? The question one. They need to go and do it now. One of your friends can eat. But I know. I want to get. You know what I do it? All right. How much you get? Mason? 70? I'm going to work on the 30% coming up. We move at 70 to 80 something next week. You know? You have to move it up. So you guys, you know, market people. You know, market, you market. What do you think I got 230 the marks for each question for? That's what I was telling the marks for each question. Where the market? I tell me what you get. What you get, you? Nice. Brandon. Oh, think of Brandon now. What you get? Huh? All right. What you get, mom? Scamber. Look here. I don't know around with me, you know. Go on now. Go on my market and sell and tell me what you're gonna get. And about that foolishness. Well, I can't joke about this thing and I'm telling you what's going on. Don't work, you know, you can't pass exam joke, you know. I didn't end the session yet. All right, guys, I'm going to end the session now. Bye.